different direction, okay? So when we do, so like I said, the most common way of integrating, which we're going to do, which this is what we're going to talk about this semester. This is the big thing. Like last semester, the big thing was limits and derivatives. This semester, the big thing is integration, integrating, okay? The most common way we do that is by using the antiderivative. Anti roughly means opposite, right? So which means we do the opposite of differentiation, okay? So derivative had different signs, different symbols, right? Had f prime, dy over dx, those symbols, right? Antiderivatives or integrals have a different sign as well. They have this little long S-looking thing, okay? Anytime you see that symbol, it means we're going to integrate, okay? And then you always have a dx at the end, or a dy, whatever letter they're using. So if they use y, you have a dy. If they use x, you have a dx, okay? So that's how you know that we need to integrate. So the most common way is by finding the antiderivative, okay? So first, let me start with, so let's look at, you don't have to write this down, but let's kind of get our heads around going in the opposite direction first, because we're not used to going in that direction, right? We're used to saying, here's an original, the derivative is this, right? So if I said this is the original, x squared plus 4x minus 2, right? We're used to saying, oh, okay, so that means the derivative is 2x plus 4, right? Now, the game has changed. Now we got to go in this direction. So what I want to do is come up with a rule. What's a rule we can do to come up with, to take this guy and end up with that guy? What's a rule we can come up with? So so for derivatives, we have the power rule, right? The power rule says, move the power to the front, subtract the power, right? That's how I got 2x. Move the power to the front, subtract the power. That's how I got 4, right? And then negative 2 doesn't have a power, so that just became 0. So plus 0, right? That's the power rule for derivatives. What's the power rule for antiderivatives? How do we get from over here to over here? What's the rule going to be? Take a look at it.
Take the coefficient that explains all.
So, yeah, so that's what happened, right? Got to put this guy back over here, right? So instead of going down a power, when we do antiderivatives, we're actually going up in power, right? So that's one of the rules, definitely. So let's write this down. Let me write this down. We're going to add a power, right? We're going to add a power. So we're not subtracting a power. Makes sense, right? If we're going in the opposite direction, if we were finding derivatives, we were subtracting a power. If we're going in the opposite direction, we're adding a power, right? That's the first one, okay? There's one other part to it.
Add an x to the numbers that are alone.
Say again?
Add an x to the numbers that are alone.
So yeah, so this guy's going to get a power. So 4 is going to get a power, right? That's the same thing. Right now, this 4 over here, x to the 0 power, right? So it's going to get a power. So it's going to get a power, right? Here's my question. How do I get rid of that 2? Because I want to make this guy into this guy, right? So we already talked about the power. Add a power. Give it a power. Give 2x a power. Then it has 2. How do I get rid of the 2 in front, though? What am I going to have to do? It's actually easier than you think.
Didn't you put it in the graph like it's -2 over there?
So yeah, so let's focus on, let's go piece by piece. So yeah, there's going to be pieces here, right? So this guy becomes this guy here, right? So we talked about the power. I give it a power, n plus 1. Power goes up, right? How do I get rid of the 2? Because over there it's a 2, right? Over here it's a 1. The coefficient is 2 over there, 2x. Now the coefficient is 1. So how do I get rid of that? Or this guy over here, right? Because technically we don't write this part, but this is actually x to the 0 power, right? So we add a power, we give it a power.
You divide by n plus 1.
Divide by the new power. That's it. Yep. Divide by whatever power it has now, the new power. That's what you're going to divide by. So let's use that. Let's see if it works. This guy here. So 2x is going to get a power. So it's going to go from 1 power to 2 powers. Divide by the new power. What is the new power? That matches, right? Those two guys match now. Let's do it with this guy. 4x, we give it a power, right? Divide it by the new power. What's the new power? 1. 4x. That guy matches too. Where does the negative 2 come from, though? It's kind of a trick question. So when we're going in this direction, when we're doing antiderivatives, we have to account for, hey, there could be right here, there was no way to tell, right? There's nothing out there. We're done. But we have to account for there could be something left over. So what we do when we're doing antiderivatives is we say plus C, plus a constant. There could be a constant out there. I don't know what constant it is, but there could be a constant out there. So that's the only thing when we're going in this direction. Okay? So that's the rule there. That's the rule. So let's write that down on our papers. Let's write that down. So the power rule it's called the power rule. We add a power and then divide by that same power. So we give it a bigger power, we add a power, the opposite of subtracting a power, like we did with derivatives. And then we got to divide by that new power. Okay? So let's do the first one. This is the derivative, 1a. This is the derivative, 2x. So we need to find the original. Right? So we're going to use an antiderivative. So 2x, what power does x have right now with the derivative? So let's give it a power. Give it a bigger power. So we add a power. And then we have to divide by that new power. Whatever the power became, we divide by. So that just becomes x squared. So the antiderivative of 2x is x squared. The derivative of x squared is 2x. You're just going in the opposite direction. Okay? 1b. What power does 1b have right now? 1. So once we know that, we can use our power rule. The power rule says, give it a power, Add a power, divide by that new power. So you can either write it like that, or you can write it like that. Either one. You can say divided by 2, or you can say 1/2. It's the same thing. Dividing by 2 and taking a half is the same thing, right? Okay. Letter C. Do letter C right now. Try letter C. Yeah. Yeah, go. Yeah, go ahead. So we add a power, divide by that new power. So you can either leave it like that, or you can change it to this. Either one of those work. Okay. Letter D. This is a fraction. Is there a way we can change that so I can use the power rule? X to the -1, right? X to the -1, because we don't have a quotient rule. That's the thing with antiderivatives. There's no quotient rule. There's no product rule. There's a lot less rules, which is nice, but you have to make the rules that you do have work. So change it to the -1. What happens when we use the power rule here? It becomes x to the 0, which is okay. X to the 0 is 1. But what happens here? Can't divide by 0, right? It becomes undefined. This is the only time the power rule won't work for this guy here. So we'll make a little note. Let's make a little note. This is the only time we can't use the power rule. And there's a reason why. Think back with derivatives. When did we see? We saw that guy with derivatives. When did we see that, guys? Anyone remember? When we took a derivative of a natural log. Yeah, natural log. The derivative of a natural log was that guy. So that's the only time the power rule won't work. Because the derivative of a natural log is 1 over x. So if I do the antiderivative, it works. The antiderivative of 1 over x is a natural log. Okay. So make a note on there on your notes that if you have that guy, it won't work. 1 over x. Oops, should be letter E. This guy will, though. This guy will. Do the same thing you did earlier. Change it to -3. Power rule. Add a power. So if I add a power to -3, that makes -2, right? Then divide by that new power. Okay. Clean it up a little bit. I got a negative exponent, right? So if it's a negative exponent, I'm going to move it to the bottom with the -2. So it'll be -2x squared. And 1 on top, which is the same thing as negative. So you can use it for negative powers. It works. The only time it doesn't work is if you have a -1 power. A -1 power. That's the only time you can't subtract the power. Okay. Okay, so Now let's look at some rules, some integration rules. Oh, whoops. Sorry, guys, I forgot something. For each of these, we have to take into account that there could be remember when we said we have to take into account there could be that guy? So anytime we're doing antiderivatives, we always want to put a plus c in. Plus c means a constant. There could be a constant out there. Anytime you're doing antiderivatives, you want to put that plus c out there. Unless they tell you differently, put the plus c out there. Okay. So don't forget the plus c like I did. Okay. All right, so now let's look at it. So like I said, anytime you see that little S symbol, that little S, this little extended S, that means antiderivative. That means integral. The most common way you integrate is by finding the antiderivative. So that's why we're doing antiderivatives. Okay, so the first rule. First rule is if you have A. A is just a number. A isn't a variable, A is a number. So the antiderivative for just a number, we're going to give it a power, right? So it's going to get a power. It's going to get 1 power, right? And then we're going to divide it by that new power, which just pretty much means it's ax plus c. So if you have, so the antiderivative of a number, of a constant, you just give it an x. You just give it a variable. Okay? Number 2 is the power rule. Number 2 is the power rule. So we add 1 power, divide by that same power. Don't forget about the plus c, though. Power rule, we add a power, divide by that new power. Whatever power it gave, whatever power it ended with, that's the power it gets on the bottom. You divide by. Number 3 we saw, right? -1. If we use the power rule for number 3, I'm going to get something that doesn't work. So what is the antiderivative for number 3? ln of x, yep, and then plus c. Right, that's the special case. That's that special case. So if you're adding 2 functions, you can just do the integral for one of them. Oops. You can split them up. You can split them up like that. You can do them together or you can split them up, just like derivatives. Okay. So now we have a constant in the front. So now we have a constant before the function. Well, just like with derivatives, you can actually move it to the front. So if we have a constant in there, you can move that to the front and then do the antiderivative. So whatever a is times the antiderivative. As long as it doesn't have a variable. As long as it doesn't have a variable, you can move it to the front. Okay, so number 6. What is the antiderivative of the derivative? What is that going to do? If I find the antiderivative of the derivative, what am I going to end up with? The original. The original. You're going to end up with the original. That sounds kind of common sense, but actually it's a pretty big part of what we do, what we're going to do in a few weeks, is they're going to ask you to do that part. Same thing with number 7. Number 7 is the same question as number 6. They just use different symbols. Instead of f prime, they use d over dx. D over dx says find the derivative of the antiderivative. Find the derivative of the antiderivative. That's just the original. So they will mix up antiderivatives with derivatives. And we won't see that for a while, but it is possible. But you're just back to the original. Okay. All right, so let's do some more practice. Do numbers 1 and 2. Do numbers 1 and 2. So number 1, antiderivative of 7x. Don't worry about that dx part. So that dx part, don't let it throw you off. It's just always at the end. I'll explain why it's there. There's a reason why it's there, but it doesn't matter in terms of finding the antiderivative. It doesn't affect the problem. There's a reason why it needs to be there, and I'll talk about that probably next week. Why? But for right now, it won't affect the problem. Your focus is just this part here. Okay, the antiderivative of 7x. So we give it a power, divide by that new power, plus c. Add a power, divide by that new power, plus c. Okay. Number 3, it's just 3 individual problems. You're just finding the antiderivative of 2x, the antiderivative of 3x squared, the antiderivative of negative 5x to the 4th. It's just kind of 3 problems mixed together. So the antiderivative of 2x is 2x squared divided by 2. The antiderivative of 3x squared is 3x to the 3rd divided by 3. The antiderivative of 5x to the 4th is 5x to the 5th divided by 5 plus c. You just need 1 plus c, so you just put it at the end. So luckily, these all divide to make 1. So it's positive x squared plus x cubed minus x to the 5th plus c. Okay. Number 4, if we were finding the derivative of this guy, we would use the chain rule, right? The chain rule said move the 2 to the front, subtract a power, then do the derivative of the inside, right? But there is no chain rule for antiderivative, so we can't use a chain rule. So is there another way to do this? What's another way we could do this without having to use by using the power rule? What can we do with those two guys? Multiplication, right? Foil or multiplication box, multiply them. First, outer, inner, last. So multiply the first terms, you get 9x squared. Multiply the outer terms, you get negative 3x. Multiply the inner terms, you get negative 3x. Multiply the last terms, you get positive 1. Combine like terms. So this is the same thing as that question. They're the same question. One's is multiplied, one's not. So now, this looks exactly like the problem we just did. So we're going to do that. 9x, add a power, divide by the new power. 6x, add one power, divide by that new power. 1 doesn't have an x, so I'm going to give it a power, divide by that new power, plus c. So we're going to get 3x cubed minus 3x squared plus 1x plus c. Add a power, divide by the new power. Does it have a power? Give it a power. Okay. All right. Number 5. So number 5, if we were doing number 5 last semester and we were saying find the derivative, we'd probably use the quotient rule. But again, there is no quotient rule. There is no product rule. There is no chain rule for antiderivatives. So we got to figure out a way to do this problem without those. Well, what's the first thing you would do? What's the first thing we would do about this guy? Perfect, yeah, change the root to a power, right? So x plus 1, x to the 1/2 power. That's the first step, good. So instead of moving it up, you're close. Aren't both of these guys, x and positive 1, being divided by the same thing? So let's rewrite it so we can give them both a divided by the same thing. You could also do that. You could also move it up. That would work too. You could also move it up and then distribute. That would work too. Or you can say, okay, so x is divided by x to the 1/2. 1 is divided by x to the 1/2. We can simplify those too, right? I have x on top and x on bottom. What do I do to the powers when I have x on top and x on bottom? Subtract them, right? So 1 minus 1/2, 1/2. I can't subtract powers here, but I can move it up to the top, right? I can move this guy to the top and give it a negative 1/2. They have powers. I can use the power rule. So we're going to add a power. So when I add a power to 1/2, what am I going to get? 3/2, right? Divide by that new power. When you divide by a fraction, what are you really doing? Multiplying by the reciprocal. So instead of dividing by 3/2, let's just multiply by the reciprocal, 2/3, 2/3. Same thing. If I were to add 1/2, add a full power to negative 1/2, what did I just get? positive 1/2. Divide by that new power. So instead of dividing by 1/2, what am I really doing? Multiplying by 2. Don't forget about your plus C, and you are done. Okay. All right, number 6. So now they're using Y's instead of X's. It doesn't change anything. Doesn't change anything. They use a different letter. So what do we do here? What's the first thing we're going to do here? Change the roots to powers, right? Change the roots to powers. So it's going to be 2y to what power? 1/3. Good. 1/3. Minus 4y to the 1/4 dy. Power rule. Add a power to 1/3. So if I add a whole power to 1/3, 3/3, right? I get 4/3. Divide by 4/3. So when I divide by 4/3, I'm really multiplying by 3/4. Good. 3/4. Let's do it again. 4y, if I add a full power to 1/4, it becomes 5/4. Divide by 5/4, you're really multiplying by 4/5 plus C. Okay, so now we got to multiply. Multiply and we're done. 3/4 times 2, you get 6/4. 6/4 can be reduced to 3/2. 4/5 times 4 is 16/5. That one can't be reduced. Done. Okay. Let's see. So those are the power rules, which you're going to use a lot because antiderivatives don't have the quotient rule, the product rule, the chain rule. There's one more thing called U substitution, but we'll talk about that later. That's kind of their everything else. So instead of having a product rule, instead of having a quotient rule, instead of having a chain rule, for antiderivatives, they kind of packaged it all up and called it U substitution. We'll talk about that next week. Next week is when we'll talk about U substitution. Okay? But for right now, just the power rule. Trig. Well, trig, we're just going in the opposite direction, right? We're just going in the opposite direction. So what's the antiderivative for sine? In other words, if I found the derivative of what would I end up with sine? Negative cosine. Good. Negative cosine plus C. What's the derivative of cosine? Sine. You're just going in the opposite direction of what you're used to going. What is the derivative of secant squared? Tangent. Because the derivative of tangent is secant squared. What's the derivative of cosecant squared? So this one is cotangent, but the derivative of cotangent, I believe, let me double check, is negative. Yeah, negative. So that means we got to give cotangent a negative cotangent. Because the derivative of regular cotangent is negative cosecant squared. Secant x, tangent x. That's the derivative of secant, right? Or the antiderivative of secant plus c. Number 6 is like number 4. It's usually negative cosecant x, cotangent x. So we got to put a negative cosecant x plus c. Okay. Let's see. We'll do the rest tomorrow. We'll finish up tomorrow. Yeah, so as long as you have those are all on the back of your trig ratios, the trig. On the back, the top is derivatives, which we did all of them last semester. Now we're going to start with this semester. So that's where the bottom is, the common ones that you'll see. We'll talk about all of them, but for right now, today we talked about 1, 2, 3, 4, 5, 8, 9, 10, 11. It's a lot of those, okay? So we'll talk about the rest of them throughout the semester, okay?